Assalamualaikum and hi everyone. I'm Tasiran Surini Abdul Rahman. This video is recorded for BEJ10102 computer programming student. Alright, if we look at the lecture and lab activities for this semester, since we are in week 2 this week, so I will be explaining you about chapter 1, which is on introduction to programming concept. Okay, this is the first slide, whereby in this slide consists of the link of YouTube, okay, on why you need to learn programming. Okay, so maybe after this class, you can watch this video on your own. Okay, alright. The first part of chapter 1 is about the terminologies often used in computer programming. Okay, the first one is a program. Okay, what is a program? A program is a set of instruction or statement for a computer to follow. Okay, if we look at this figure, actually this is a part of program. This is not a complete program. Okay, this program consists of several instruction. This one is known as instruction or statement. Okay, this one is the instruction. This one is the other instruction. This see out is also an instruction. Okay, so a collection of instruction, we call it as a program. Alright, now we move to the second terminology, which is software. Okay, you always say software, but what is software? Okay, software is a collection of computer programming or instruction or data used or stored by a computer. Okay, just now I show you the programming, or one program, but maybe maybe there are several programs combined together, and the manufacturer make it as a software. Okay, the manufacturer combine all the program and develop a software to do some application. Okay, so the example of software, we have for example Microsoft Word, Microsoft Excel, we have Microsoft PowerPoint, Visual Studio C++, and many others. Okay, that one is the example of the software. Okay, the third terminology is hardware. Okay, what is a hardware? Hardware is an actual machine that make up a computer installation. Okay, so to run the software, you need a hardware. Okay. Alright, this slide shows the history of C++. Okay, this is the man, the inventor of C++, whereby C++ is an extension of C language. Okay. Alright, this slide shows a simple view of running a program. Okay. For example, you have C++ program. Okay, then you want to run this program, so you need a computer. Okay, and then of course you need a data input from the user. Okay, let's say the user key in the data by using the keyboard. Okay, keyboard is one of the example of input device. Okay, and then the computer through software will run or will execute the program. Okay, and then the output will be shown on your computer screen. Okay, so computer screen is one of the output device. Okay, alright, this one is the example of application of computer programming. Okay, for example, you want to detect or you want to read room temperature. Okay, so you need a program to do so, to do the reading of room temperature. Okay, so you have here you have a sensor, room temperature sensor. Okay, and then you have an Arduino board as a microcontroller. Okay, and then of course you need a computer. So you develop a program by using a computer. Then you download the program onto the Arduino board. Okay, this is the IC, and then the Arduino board will be connected to the sensor. Okay, and then the reading of the sensor will read the room temperature and will send back the data to the Arduino board, and this Arduino board will be process the data. Okay, or with the assistance of computer. Okay, so by using the computer programming, you can do a simple only a simple project, but a big project also you can do by using a computer program. Okay, so this is the example of the application of computer programming. Okay, you can use the computer programming to control or to read the room temperature. Okay. Alright, this one is the flow of compiling and running a C++ programming. Okay, so you have a C++ programming and you need a compiler. Why you need a compiler? Because what is the function of compiler? Okay, compiler is used to translate a high-level language into a machine language or machine code. Okay, so C++ is one of the high-level language. Okay, besides C++, we have Java, we have MATLAB. Okay, so we have so compiler is used to translate this high-level language to the machine code. Okay, why? Because computer is not understand the high-level language. Computer only understand the machine code or a machine language. So we need a middle party, or we need a compiler to translate the high-level language into the machine code, so that computer can understand and can execute the program. Okay, so we have after the program is compiled, we have object code here. Okay, so what is object code? Maybe I can show you the next slide. What is the the object code? Okay, so this is the program. Okay, the program, this one is a program, or also known as a source code. So a program or a source code is a programming code that has not yet been compiled into an executable file. Okay, this one is not yet compiled, we call it as source code. Okay, and then we have a compiler to translate this high-level language into machine code. So the compiled code, we call it as object code. Okay, what is object code? Object code is compiled code that can be run on any computer with the same CPU architecture. Okay, this one is the object code. Okay, so we have a program, then we have a compiler to translate the high-level language into machine code. And when we compile the program, we know that program as object code. Okay, and then we have a linker. What is the function of linker? Okay, linker is a program that combines object code. Okay, for combine object code with the object code for routine, such as input and output routines. Okay, this one is linker, and then the executable file will be produced. Okay, .exe file. Okay, so this one is the executable file. Okay, this is the what happen when you compile and when you run a program, for example, C++ program. Okay, all right, so this one is types of error in computer programming. This is the basic error that computer programming have. Okay, for the first one is a compiler or syntax error. Okay, syntax error means maybe the programmer spell incorrect instruction. Okay, for example, the reserved word "see up," okay, must be spelled in a small letter, but the programmer type in upper letter or apa in a capital letter, I mean, okay, sorry, the programmer type in a capital letter, so it will produce a syntax error. Okay, another example is when you want to do a division operation, mathematical operation, division operation. Suppose you use this black slash symbol to represent the division process, but you as a programmer, you incorrect you type the symbol of division incorrectly, so maybe you use the slash here. Okay, this is not correct. So in this situation, the computer or the software or the program will produce a syntax error. Okay, another example is maybe in one program. Okay, so this is the example of program. In one program, okay, to end the line, you need to put semicolon, but sometimes the programmer forget to put the semicolon at the end of the line, so that condition will also produce a compiler or syntax error. Okay, alright, so we go to the second error, which is execution error or runtime error. Okay, what is execution or runtime error? Okay, execution error will cause the termination of program. Okay, for example, you type a mathematical operation, a division operation, I mean, and you divide that number with a 0. Okay, you divide the number by 0, so this condition will terminate your program. Okay, because in mathematical operation, if you divide any number with 0, you will get infinity. But in computer programming, it will cause the termination of the program. Okay, so this condition we known as the execution error, an execution error. Okay, alright, the third one is logic error. Okay, logic error, actually logic error, the program appears to execute properly. Okay, the program will produce the output, but the output is incorrect. Okay, later on I will show you the example. Okay, alright, the program appears to execute properly, however it produces incorrect result. Okay, because of incorrect steps in the solution. Okay, thus we as a programmer need to recheck the result and the programming carefully to make sure that we will get the correct output. Okay, okay, this is the example of logic error. Okay, in this program is about to total out the two numbers, in two integer numbers, if yes, two integer numbers. Okay, the number, the variable of that the variable of this involved in this program is a, b, and sum. Okay, so sum is equal to a plus b. So the user need to key in the value of a and the value of b, so that the computer, the program will calculate the sum of these two numbers. Okay, but the programmer incorrectly put the equation of sum before the user key in this data. Okay, so the equation supposed to be after user key in the data, but the programmer put the equation in this before the user key in data. So this result, this program will produce an output successfully, but the result is incorrect. Okay, so I show you the online compiler. Okay, I copy and paste the program into this online C++ compiler. Okay, and then I try to run the program. Okay, I enter the first number. Let's say I put it as 3, the first number. Okay, and then the second number is 2. Okay, alright, so total of 2 number is, suppose the total of these 2 numbers is 5, but the result is show a wrong or incorrect answer. Okay, this is the random number that produced by a computer. Okay, this one is a random number. Okay, so this program can this program able to give you an output. Okay, but the answer is wrong. So you as a programmer need to recheck. Okay, recheck the line by line what is the error in your program. Okay, so because why? Because the software, okay, this software didn't show you any hints of the error here. Okay, so you need to trace one by one where is the error. Okay, so the error is actually in line 11. Okay, suppose you put the equation after line 17. Okay, you put it here and then you try to rerun your program. Okay, I enter the first number and then this is the second number. Alright, now the program produce a correct answer, okay, or a correct output. Okay, so previously the condition or that situation known as a a logic error. Okay, alright, that one is 3 types of errors in computer programming. Okay, so we move to the important part of chapter 1, which is software development model, or in short SDM. Okay, so SDM is actually a reference used by a programmer, okay, in understanding the problems that has been given by a client or a customer. Okay, so in order to develop any program, you need a reference. Okay, so SDM is one of the reference. Okay, beside SDM, you have a waterfall model. Okay, you have actually many other model. Okay, but among the popular is SDM model. Okay, in SDM model, it consists of 6 steps. Okay, the first one is requirement specification. Okay, in this step, you as a programmer need to understand and define the problem that has been given by your client. Okay, imagine that one client come to you and give you a problem. Okay, tell you his or her problem. Then you need the first step is, as a programmer, you need to understand what is your client's problem. Okay, alright. The second step is data analysis. In this step, you need to go further detail. Okay, understanding the problem. Okay, in understanding the problem, okay, you need to specify. Okay, you need to imagine, or you need to draft what is the input actually of the problem of the problem given. Okay, and then what is the formula involved, what is the expected output, and what is the constraint of that problem. That one is in step number 2. Step number 3 is algorithm design. Okay, so before you develop a program, you need to draft you need to draft the steps by using algorithm design. Okay, so algorithm design can be through pseudocode or flowchart. Later on, I will explain what is pseudocode and what is flowchart. Okay, alright. The step number 4 is implementation. Implementation means you develop a program. Okay, you develop a program by using, for example, C++ language. Okay, that one is step number 4. Step number 5 is testing and verification. Okay, after you develop the program, you need to test the program. Okay, you have to give a sample, okay, several sample, and then you have to run the program, and you have to check either your program produce a correct result or a correct output or not. Okay, you have to verify your program, either your program is correct or not. Okay, that one is step number 5. And the last one is documentation and maintenance. Documentation you can relate with your lab report. Okay, after you did your lab session, okay, you need to prepare the lab report. Okay, so that one is the example of documentation. Or in real world or in real application, it can be a user manual. Okay, maybe if you develop a big or a complicated program, you need to provide a user manual so that your client or the user can use or can understand your program by reading the user manual. Okay, and maintenance. What is maintenance? Okay, maybe from time to time you have a new version of your program. Okay, so this condition we call it as maintenance. Okay, you develop a new version or you modify some part of your program to make it better. Okay, that one is maintenance. Okay, that is the 6 steps in SDM. Okay, so in order to more understand on SDM, we have 2 exercises here. Okay, the first exercise is okay, you imagine that this one is a very simple example. Okay, imagine that a client come to you and ask you to develop a program to calculate the multiplication of 2 integer numbers. Okay, so step 1 that you need to do is a requirement specification. Okay, in this case, the requirement specification, maybe you can put here. Okay, the client asks to develop a program that able to multiply 2 integer numbers. Okay, this sentence is what you understand from your client's requirement. Okay. Alright, the second step is data analysis. You have to identify the input. Okay, the input, of course, in order to multiply 2 numbers, you need 2 numbers. Okay, and then you put here 2 integer numbers. Okay, and maybe you can name the variable as num1 and num2. Okay, you also can use ABC. Okay, whatever you want, A, B, or var1, var2, any name. Okay. Okay, then you have to identify the formula. So the formula, I create one more variable to save the answer. Okay, so this one is mul. You can put any name. Mul is equal to num1 multiplied by num2. Okay, this is the formula. And what is the expected output? The expected output, of course, the multiplication of 2 integer numbers, which is mul. Okay, and maybe the output you can add on to display the result of mul. Okay, you can add on like this. Okay, alright. So another one is constraint. Okay, the constraint in this situation is the number must be in integer number because the client asks you to multiply 2 integer numbers, not floating numbers, not a string. Okay, integer numbers. So the constraint is your output must be in integer number. Input. Your input must be in integer number. Okay. Alright. The third step is design. Okay, whereby you need to develop or to draft your program through either pseudocode or flowchart. Okay. Alright, this one is exercise 2. Exercise 2 the client asks you to develop a program to compute the total value of 4 floating point numbers. Okay, so this is the requirement specification. This is example of the sentence. The client asks to develop a program that able to total the value of 4 floating point numbers. Okay. Okay, the second step is data analysis. Okay, so with the data analysis, the input is 4 floating point numbers. Okay, I name my variable as var1, var2, var3 and var4. You can put any name. Okay. Alright, so the formula is total is equal to var1 plus var2 plus var3 plus var4. Okay, so the answer will be saved in variable total. Okay, I create one more variable which is total to save the answer of this operation or equation, right? And then the output is total value of 4 floating point numbers, which is total. Okay, and then the constraint is the numbers must be in floating point numbers. Okay, this one also you can display the total. Okay, the constraint, since the client or the customer asks you to compute 4 floating point numbers, means the input numbers must be in floating points number. Okay, not integer, not a string. Okay, must be in floating point number. Okay, point form number. Okay, for example 1.0, 3.5, okay, 100.3. Okay, that one is the example of floating numbers. And step number 3 is design. Later on I will show you how to create the pseudocode or flowchart. Okay, this is the third step number 3. Okay, which is algorithm design. Okay, so we can use either one. We can draft the programming or our program through pseudocode or flowchart. Okay. Alright, we go to the first algorithm design, which is pseudocode. Okay, pseudocode describe the processing steps in a simple and narrative notation. Okay, for example, okay, this one is the example for exercise 1. Okay, pseudocode must begin with the word begin or start. Okay, and end with the word end. Okay, alright, step number 1. Of course, we ask the user to key in num1. Okay, the second step, we ask the user to key in num2. Okay, or these 2 steps can be combined together. Ask user to key in num1 and num2. You can do so. Okay, alright. So step number 3 is calculate mal equal to num1 multiplied by num2. Okay, alright. And then the last one is display the result mal. Okay, so this is an example of pseudocode. Okay, so we go to the exercise 2. This is the example of pseudocode for exercise 2. Okay, you ask user to key in var1, var2, var3 and var4, and then you calculate the total. This is the formula, and the last step is you display the result of total. Okay, you begin and end the pseudocode. Okay, alright. Next is okay, this one is another example, exercise 3. The client asks you to display high on computer screen. Very simple problem. Okay, so requirement specification, you can make a statement, make a statement. The client asks you to display high on the screen. Okay, and second step is since the user only asks you to display the word high on the screen, so there is no input actually, it's only a display. Okay, so no inputs, no formula involved, but the output, yes, of course we have the output whereby we need to display a high. Okay, a high here, and no constraint. Okay, alright, so this is the pseudocode, example of pseudocode. Okay, this is the example of pseudocode whereby you begin the pseudocode and the first step is display high on the computer screen. Okay, so you have only one step here, and right. Alright, we go to the next to the second algorithm design, which is through flowchart. Okay, you can draft your program through flowchart. Just now you learn how to draft your program or your step through pseudocode. This time is flowchart. So what is flowchart? Flowchart is a graphical symbol used to represent the flow or the steps involved in solving the problem. Okay, this one is alternative to pseudocode. Okay, so this is a symbol. This one is the begin and end symbol. This one is input and output symbol. And then we have process symbol, formula symbol. And then if this one is actually specifically for 4 symbol. Okay, this one I will explain you on chapter 3. Okay, alright, this one is diamond symbol to make a decision. Okay, alright, this one is arrows. Okay, this one to show you the flow. And then this one is on page connector, whereby for example maybe you draw the flowchart but the space is not enough and you want to continue the drawing on the same page, you can use on page connector. Otherwise you can use off page connector if you want to continue the drawing in the or on the next or on the different page. Okay, different page we call it as off page connector. In the same page we call it as on page connector. Okay, so this is the flowchart for exercise 1. Okay, alright, so I use Flowgorithm. Okay, you can download the software through this website. Okay, and you can draw the flowchart using Flowgorithm software. Okay, or otherwise you can also use the symbol inside or the drawing inside your PowerPoint also can. Okay, your Word also can. Okay, so you just drag the symbol and you can use the symbol. Okay, for example this one. Okay, you can just drag. You go to home and you find the shape format and then you just choose and drag the symbol. Okay, but it quite difficult to balance when you use the symbol in PowerPoint or Microsoft Word. Okay, by using flowgorithm, you can draw your flowchart more easy. Okay. This one maybe I can delete. Alright, so this is the flowchart, whereby this is the symbol of start or begin. Okay, or also you can put as main, since this is the main program. Okay, so you can put it main, or you can put it begin. Okay, usually we put it begin. Okay, so you begin your flowchart, and then this one is actually a symbol for declaration of variable. Okay, if you want to skip this one, it's okay. Okay, but if you put the declaration process, it's better lah. Okay, so this one is a declaration process, whereby you declare the variable, which is num1, num2 and mal, as integer number. Okay, this one is a declaration part, and then this one is the input part. Okay, input, you have two input. The first one is num1 and the second one is num2. And then this one is the formula or the process. Okay, the process is mal equal to num1 multiplied by num2. And this is the output symbol. Okay, display the result mal. Okay, and then you end the flowchart. Okay, in fact, by using flowgorithm, you can try to run this flowchart, and the software able to show you the output of this flowchart. Okay, alright, this one is actually I use the symbol in or I use the symbol in PowerPoint. Okay, which is shape format. I go to home and I use the symbol in shape format. Okay, I just drag, and then I just put the text inside the symbol. Okay, so in this slide, I want to show you how you can use on-page connector. Okay, as I previously explained, on-page connector is used when you're drawing, you need a continuity, or you need a continuation of your programming, but the space is not enough. Okay, for example, this one until this step until this process, the space is not enough. Then you want to continue your drawing on the same page, so you can use this on page symbol. Okay, and maybe you can put one here. Okay, and you continue with one here. Okay, so that the user knows that this one has a continuation, whereby in here. Okay, so one here means you continue to this one. Okay, this is on the same page. Okay, alright, so in this slide is off-page connector. Okay, sometimes you want to draw and then there is not enough space, and then you want to continue on the next or on a different page, then you have to use off-page connector. This is the symbol. Okay, maybe you can put here one, and then on the next page you put here one also. Okay, so that reader can know that the continuation of your symbol is here, one and one here. Okay, alright, that one is off-page connector. Okay, so maybe you can try to draft the flowchart for exercise 2, okay, by using flowgorithm, or you can use Microsoft PowerPoint symbol, or you can use Microsoft Word symbol. Okay, there is another one software you can use, which is Microsoft Visio, VISIO, Visio. Okay, you can type to search. Okay, you can search the Visio inside your computer, and then you can use to draw the flowchart. Okay, so this is another example. Maybe you can try after the class. Okay, this one is the exercise. You can also try after the class, and this one is the review question. Okay, so that's all for chapter 1. Okay, I already explained to you the terminology. Okay, there are three important terminologies, which is program, and then software, and then hardware. And I already explained to you 3 types of error. We have compiler error, we have execution error, and we have logic error. Okay, and then I also explained to you 6 steps in software development model, or in short SDM. Okay, and I already explained to you on how to do the pseudocode and on how to do the flowchart. Right, so with that, thank you very much. See you next week.